Hello, Math 130 students. We are going to pick up on page 8. So section 8.3, exponential functions. So for example, this graph on the right-hand side represents a function. And the exponential function in particular is f of x is equal to 2 to the x. So here we have some x values and we have our y values. So one of the things that's really important to kind of notice is that this graph is going to have an asymptote. Okay, so the exponential graph always has an asymptote at the x-axis. So here my asymptote is the x-axis. So usually it has dotted lines to represent that this is your asymptote. Okay, so that means the graph keeps getting closer and closer to the x-axis, but never actually touches it. So it's kind of like saying, hey, you will get closer and closer and closer and closer and closer, but you're never going to cross it. Okay, so that's really important to know about general information about your exponential functions. Also, we have the domain is usually negative infinity to infinity versus the range is 0 to positive infinity. If this was the asymptote, right, there isn't any negative y values. So let's think about that as we go into graphing. So for example, it says graph the function and the horizontal asymptote as needed. So here what I can do is draw some x and y values to help me go ahead and graph this thing. So remember, we really have y is equal to 3x plus 2. So if that's the case, then I can just bring up my calculator here. And let's say for the first x value, you're going to plug in a 0. I think 0 is always a good number to plug in. So we have 3 to the power of 0 plus 2, which ends up giving me 3. So my answer here is going to be 3. So I have the order pair 0, 3. So what happens when we plug in, let's say, a positive 1 into our equation? If I plug in a positive 1, then I have 3 to the power of 1 plus 2. So now I'm plugging in 2, and I get a positive 5. So now let's see what happens when I plug in a negative 1. So if I were to plug in a negative 1, I would have 3 to the power of negative 1. And I'm still adding 2. And so I get a 2.333333, right? This is going to be a fraction, and that's okay. So 2.3 repeating. So I have my first point is 0, 3. Looks like that's my y-intercept. I have 1, 5. And I have a negative 1, 2.33. Okay. So if I look at more values for my x value, looking at my graph, it looks like if I keep going negative, more and more negative, my value, it will not go beyond positive 2. So let's see what happens when I plug in a negative 8. If I plug in a negative 8 into this equation, so 3 to the power of negative 8 plus 2, it gives me 2.000015, right? So it never goes behind the 2 or below the 2. So this pretty much tells us that we are going to have an asymptote right at 2. So it was 2.00015. So right above the 2. So now I know that my graph is going to look like this, more or less, right? So my asymptote is going to be right at 2. And you can also tell that whatever it's added or subtracted from your exponential function will be your asymptote. So here my asymptote is y is equal to positive 2 will be your asymptote, right? It's adding 2. So that is my asymptote of 2. So I have graphed the function and the horizontal asymptote. Now let's look at number 2. So here again, I'm going to look at some x and y values and graph some of these points. So I'm going to bring up my calculator. So I have well, it might be helpful if I rewrite this as a y is equal to 4x plus 1, right? So now when I'm plugging this into my calculator, I'm going to plug in some values for x. So I don't know, let's plug 0 first. So I'm going to have in my calculator 4 to the power of 0 plus 1, which gives me a positive 4. So now let's try a positive 1. So I'm going to have 4 to the power of a positive 1 plus 1. So now in here, I'm plugging in a positive 1 in for x. So 4 to the 1 plus 1 gives me 16. So let's see what happens when I plug in a negative 1. So if I'm plugging in a negative 1, then I would have a 4 to the power of negative 1 plus 1. And that gives me 1. So it looks like if my numbers are negative, I'll still be on my graph. So let's see what happens when I plug in a negative 2. So 4 to the power of negative 2 plus 1 gives me a 0.25. So I'm starting to see the pattern, but if not, you can always plug in more. So let's say now you want to plug in a negative 3. If I plug in a negative 3, 4 to the power of negative 3 plus 1 gives me a positive 0.0625. So it looks like it's never ever going to be crossing my 0 power. So just to make sure, if I were to try to guess, let's say negative 10, then I have 4 to the power of negative 10 plus 1. And that gives me a 3.8 blah 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 e to the negative 6 power. Remember, e on your calculator represents scientific notation. So this is really 0.00003816, or 3 point. So let me write this down actually. So if I have 3.18 and it says an e to the negative 6 power, this is really scientific notation, so it's 3.18 times 10 to the negative 6. So that means I'm going to move my decimal over 6 times. 1, 2, 3, 4, 5, 6. So I'm going to have 0.12345 right? So 1, 2, 3, 4, 5, 6. Yep. So this is a really, really small number. So again, it does not go past 0. So now I have my points. So I have 0, 4. I have 1, 16, that's just like way up here. I have negative 1, 1. Oops, and that was a negative 1, wasn't that? So let's actually go to a negative 1 here. There we go. So that's negative 1, positive 1. There we go. And then we have a negative 2.25. And then we have our negative 3. And we have our negative 10, which is, just getting closer and closer to the x, but never really crossing it. And notice here that my asymptote is exactly on the x-intercept. Okay, and that's my graph. Now, for the next example on page 10, it says evaluate f of x when x is equal to -2. Give an approximate answer rounded to 2 decimal places. So here we are talking about e, and if you're wondering like what the heck is e? E is a number. So if I'm talking about e on your calculator, it's a number. Remember how pi, we usually say it's 3.14, but there's actually more decimals for pi. So if I type pi, it's 3.1415926, right? It keeps going forever and ever and ever, never ending, never repeating. So it keeps going over. It's an irrational number. Well, e is going to be very similar to pi. So our e, and we really say it's going to be like an e to the 1. Is at 2.718281828, and it's never ending, never repeating, just like that pi was. Oops. It was 2.71828. Right? So it was at 2.7128, and then it kept going and going, never ending, never repeating. Okay? So that is my e function. So when it specifically says to evaluate this, well, this is what I'm plugging in. I'm saying that my y value is e to the 4x plus 5. So they're saying, hey, this x value, plug in x is equal to -2. So now I have that y is equal to e4 plus 5. So the value that you're plugging in there for x is a -2. So I'm going to go ahead and plug that into my calculator so that I have an e to the power of 4 times -2 plus 5. So I plug that into my calculator and it gives me this decimal. So I'm going to go ahead and copy this decimal down. So it is 0.04978, right? Let me just make sure I wrote it down right. 0.04978, yeah. And it keeps going, right? But it specifically says to round to the 2 decimal places. So if I'm rounding to 2 decimal places, well, here's my 2 decimal places. So that 9 is going to tell me what to do. Well, it's going to tell me to bump it up. So this is going to be 0.05. So I know that my function f of -2 is equal to 0.05. That is going to be my final answer. So for number 2, it's the same process. So I have that y is equal to e to the x times e to the x minus 1. So here what I'm plugging in for my x value is 2. So I have e to the x value times e to the x value minus 1. And that value that I'm plugging in is a 2. So now I'm going to plug that into my calculator. So I'm going to have e to the 2 power, so e squared, times parentheses, there's my e again, and it's squared, and I subtract 1 and close my parentheses. So I'm going to get 47.209. And the reason I just want to go to, or how many, it says go to the 3 decimal places, so that means I'm going to go to 4. So it was 47.20909. So by 4 decimal places, I mean we're going to look at our 3rd decimal. So that 4th decimal is going to tell us what to do. So this tells us that y is equal to 47.209. So I know that f of 2 is equal to 47.209. And that ends up becoming my final answer. And we're going to do the exact same process for example number 3. So we have that y is equal to e to the 4x plus 8. And here that x value is going to be a -3. So I'm going to just plug this into my calculator, and it says to round to the 3 decimal places. So I'm going to have my e value 4 parentheses -3 plus 8, and that's going to equal to a 0.0183. Okay, good. So since it says to round to the 3 decimal places, there's 3. So that fourth digit tells us what to do. It tells us to leave it alone. So y is equal to 0.018. So now I know that f of -3 is equal to a 0.018 as your final answer. For number 1, it wants you to go ahead and use some properties that you know of exponents. So you know how to do this. So I know that I have rows of exponents, and I know that what I can do here is I can multiply by an e99 to both sides. So if I have the fraction e to the x squared, e to the 99 is equal to e to the 2x, that would multiply by e to the 99 over 1. So that here it cancels. I'm left with e to the x squared is equal to e to the 2x times e to the 99. And because of our rules of exponent, well, that tells us that these x values here, or these powers, these exponentials, because it's being multiplied, I can add them together. So now I have e to the x squared is equal to e to the 2x plus 99. So now that this is true, what I can do is if I'm saying, hey, if my bases are both e's, then all I have to worry about are my exponents. The exponents must be true. So this means that x squared is equal to the 2x plus 99. And now this just looks like a quadratic that I can solve, so that I can have x squared minus 2x minus 99 is equal to 0. So if I were to factor this, my multiples of 99, or my factors are 1 times 99, 3 times 33, and 9 times 11. Well, if I were to choose the 9 and the 11, when I add them together, it would give me a -2. So I have x minus 11 times x plus 9 is equal to 0. So what I did here is I factored. And if you guys are comfortable with the AC method, that's fine. I did A times C in my B value, where I had my 99 and it had to add up to a -2. So the only values that would work here would have been my -11 and my +9, if you like the AC method. So that's exactly what I did, except I just did it with guess and check, but it works out the same. So now I have that x minus 11 is equal to 0. So x is equal to +11. X plus 9 is equal to 0. So x is equal to a -9. So what I want to do here is I just want to check my solution. So I have my fraction. So on this particular calculator, depends on your calculator, but for this one, I'm going to go to alpha and then y equals. It gives me the fraction. So I have an e that I'm plugging in. And that first value that I'm going to plug in is a positive 11. So I'm going to have my exponent here. And it's 11 squared, since I'm plugging in x is equal to 11, over my e to the 99. And I want to know if that's the same as e to the 2 times my 11, since 11 is what I'm plugging in. And it does equal the exact same thing. So when I have x is equal to 11, it definitely works. Now I'm going to try this exact same thing, but now with my other value of x is equal to a negative 9. So I'm going to have my e value, and what I'm plugging in here is a negative 9, and it's squared. Let's try that again. So I'm going to do my alpha, y equals my fraction, and I have my e, and it's a try that again. Calculator's gonna be so messy. Okay, so here we go. We have our e to the power, and here I have my negative 9 that I'm plugging in, and it's squared over my e to the 99. And is that going to be the same as my e to the 2 times my negative 9? And it is the exact same thing. So both of these are good answers. You always want to check it to make sure. So x is equal to negative 9 and x is equal to a positive 11. Now for number 2, I can see that my base here is 6, but I can also rewrite 36 to be base of 6. I know that 6 to the 1 power is 6, but 6 squared is equal to 36. So this is how I'm going to rewrite that 36. So this side does not change. And now, since I have 36 over here, that can just be written as 6 squared. So now I have the same base, so I can set my exponents equal to each other. So negative 3x minus 1 is equal to a positive 2. So I'm going to have a negative 3x is equal to a positive 3. So x is equal to a negative 1. And of course, you always want to verify. So I'm going to plug it into my calculator. So is it true that if I have 6 to the power of negative 3, and the value that I got was a negative 1 for x that I'm plugging in, and I have a subtract 1, does this equal to 36? It does. So I know that x is equal to negative 1 is a good answer. And now I'm going to try the exact same thing for our 14. Well, I see what I did wrong for number 3. There is a typo. This should really have been 12 to the 4x minus 41 is equal to 1728. Otherwise, it's a lot harder. So if we think about it that way, sorry about that typo, I have 12 to the 1 power, which is 12, 12 squared, which is 144, but 12 to the third power is 1728. So that's exactly what I have here for 1728. So I'm going to rewrite this. So I still have 12 to the 4x minus 41, and I have 12 to the third power, since that's equal to 1728. So now I can set my exponents equal to each other. So I have my 4x minus 41 is equal to my other exponent, which is 3. So 41 plus 3 gives me 44. So x is equal to 11. So when I have this on my calculator, 12 to the power of 4 times 11 minus 41, it should equal to that 1728. And it does. So I know that x is equal to 11 is going to be my final answer.